All right, let's dive into a world that, for pretty much all of human history, was completely invisible. A world teeming with life that, believe it or not, holds the power of life and death over every single one of us. This is the story of the scientists who first peeked into that world, and in doing so, changed our own forever.
I mean, just think about that for a second. For thousands of years, you had plagues and diseases just wiping out entire populations, and nobody could see the killer. It was a total mystery. People blamed it on, bad air or curses or punishment from the gods. But the real culprits? They were there the whole time, just operating in the shadows.
And that's the thing. The moment a human eye first saw a microbe, that was the spark. That's what ignited a revolution in medicine. It wasn't some loud, flashy explosion. No, it was a quiet, stunning revelation through a simple piece of glass that would go on to save literally billions of lives.
Okay, so before we meet the pioneers who built this field, let's quickly get on the same page. What exactly is the science they created?
At its heart, clinical microbiology is the science of us versus them. It's the playbook we use to identify, understand, and then defeat the tiny invaders, the bacteria, viruses, and fungi that cause infectious diseases. It's the bedrock of so much of our modern public health system.
Now, in this invisible world, there's a really fundamental divide. On one side, you have the simple prokaryotes, like bacteria. They've got a single circular chromosome just kind of floating around. But on the other side, you've got the more complex eukaryotes, like fungi, which have multiple chromosomes tucked away in a nucleus, just like our own cells. And trust me, this difference is absolutely crucial. It's how we figure out how to kill them without harming us.
So, how did this whole thing even begin? Well, the journey doesn't start in some fancy high-tech lab. Nope. It starts with a humble cloth merchant who just happened to have a wild sense of curiosity. He was the very first human to witness this hidden world.
This is the man Antony van Leeuwenhoek. Back in 1676, using a super powerful single-lens microscope that he built himself, which is amazing, he scraped some gunk off his own teeth, put it under the lens, and saw something that must have just blown his mind.
Little animalcules, that's what he called them. He saw these tiny, living creatures just swimming and darting all over the place. For the very first time, humanity had proof that an entire unseen world of life existed. But here's the crazy part. It would take another 200 years before anybody made the connection between these animalcules and disease.
And that brings us to the hero of our story, a French chemist whose work would completely flip centuries of medical belief on its head.
Meet Louis Pasteur, and he has earned his title the father of microbiology. His work started with something pretty practical, fermentation in wine and beer, but it led him to a discovery that was, well, infinitely more important.
I mean, just look at this list. The sheer scale of Pasteur's impact is staggering. He gave us pasteurization, the reason the milk in your fridge is safe to drink. He created the first vaccines for terrifying diseases like rabies. He invented sterilization tools like the autoclave, which are still used in every single hospital today. His work is everywhere in our modern lives. But this was his masterpiece, the germ theory of disease. He put forward this idea that it wasn't some mysterious bad air or miasma that made people sick. No, it was specific, living germs. Now, that sounds obvious to us, but back then, it was an absolutely radical idea. It meant that disease had a physical cause, and if it has a cause, you can fight it. You can kill it.
Okay, so Pasteur had the theory, which was brilliant. But science, demands proof. You need a rock-solid, repeatable method to prove that this specific microbe causes that specific disease. And the man who gave us that was a German doctor. And here he is, Robert Koch. If Pasteur was the grand theorist, Koch was the master technician. He was the one who developed the tools of the trade, things like using solid stuff like agar to grow pure colonies of bacteria, and using special stains to make them pop under a microscope. And then he laid down the law with these 4 postulates. Think of it like a detective's checklist for pinning a microbe to a crime. 1, you gotta find the suspect at every crime scene. 2, you have to isolate the suspect, get it all by itself. 3, you use it to recreate the crime in a new victim. And 4, you have to find the suspect in that new victim. This was the scientific bedrock that proved germ theory was for real.
But of course, science is never quite that simple. Koch's really elegant rules don't always work perfectly. Some microbes, like the one that causes leprosy, are just stubborn and refuse to grow in a lab dish. For others, like the bug that causes gonorrhea, we just don't have an animal we can test it on. It just goes to show you how complex this invisible world really is.
So, the theory is proven. The rules are set. The race was now on to actually use this new knowledge to save lives. It was time to build an arsenal. Joseph Lister was one of the first to have that light bulb moment. He thought, hey, if germs cause disease, then killing germs in the operating room should stop patients from getting sick after surgery. And he was right. By using carbolic acid to clean wounds and sterilize instruments, he completely transformed surgery from a terrifying gamble into a life-saving procedure. He became the father of antiseptic surgery for a reason.
Next up, another genius, Paul Ehrlich. He had this incredible thought. He wondered, if we can use special dyes that only stain specific bacteria, could we create a chemical that would only kill those specific bacteria and leave our own human cells totally unharmed? He called his idea the magic bullet. And after hundreds and hundreds of failed experiments, he found it, Solvarsen, the first truly effective treatment for syphilis. This was the birth of chemotherapy, the whole concept of targeted destruction of an invader without destroying the host. It was a breakthrough of epic proportions.
Look, the discoveries of these pioneers weren't just dusty old historical facts. They lit a torch that's been passed down through generations of scientists, lighting the way for the medical breakthroughs we all count on today.
And the pace just keeps getting faster and faster. In 1929, a happy little accident in a lab gives us penicillin, the first antibiotic. Then, fast forward to 1977, and we're literally decoding the building blocks of life by sequencing microbial DNA. Then, boom, 1993, PCR technology lets us amplify tiny bits of that DNA, a tool that would be absolutely essential for discovering HIV in 2008. You see, every breakthrough stands on the shoulders of the one before.
It's really a breathtaking journey when you think about it. We went from seeing little animals for the first time, to understanding their genetic secrets, to designing precision weapons to fight them. So the next time you take an antibiotic, or get a vaccine, or have a safe surgery, just remember you're benefiting from the work of these giants, the invisible architects of our modern medical world.
And that brings us to today, doesn't it? We're in a new chapter of this ancient battle. The principles these pioneers gave us are still our best weapons against ever-evolving threats like superbugs and new viruses. But as we've learned, the invisible world is always full of surprises. So the real question isn't if a new challenge will show up, it's when. And will we be ready for it?